Hello all learners, welcome to the session of Geometric Tolerance, Methodology at GD&T approach. Myself Rohit Bhaskar. Now in today's session we'll discuss about the geometrical tolerances. So most probably geometrical tolerances relates with the surface properties. So if you observe this figure, this hatched position indicates the datum surface. So datum surface may be the component which is related as on which we have to provide the geometrical tolerance. Now for providing that, this will be the methodology, that is a triangle indicated as a datum triangle, and alpha beta we call it as a datum letter in a square blocks. So this will be the reference surface as we call it. Then we have this as a relation component, that is, suppose this is the tolerance feature, you have to show the relation between the A and the surface. So this will be the arrow line or and leader line, and three box will indicate the reference. Now in first block we will have a tolerance symbol, then in second block we have tolerance value and datum letter over here. So representation style of a geometrical tolerance will vary accordingly. Now we have tolerance feature over here, which will be indicated as in this fashion, which will be a correct methodology. If the tolerance feature is over here, and if we are showing the relation and reference away from the surface, so that may occur if we have to show any type of a dimension. But if dimension is included over there, so we are not able to show that. Then we have another circular component or a cylindrical component. So reference may be taken for the surface or either to the axis. We can continue with this as a reference. Then related to geometrical tolerancing symbols, so we have classification of geometrical tolerance as based on form of a feature, based on orientation, or based on the position. So based on the form of single features, we have straightness, flatness, cylindricity, circularity, profile of any line or any surface. In this case, this will be the following symbols which we'll be using. Then we have orientation. In orientation case, parallelism is there, perpendicularity is there, and angularity is there. And in positioning case, we have position symbol, concentricity or coaxiality, symmetry, or either run out. Now we'll try to discuss one by one the detail. So first we have a straightness. So straightness will be used to control the straightness of a line with respect to surface. Now how? Suppose this is the one line whose reference is to be shown with the datum surface. So that time the maximum tolerance value will vary accordingly. Now over here, if you observe in detail, we have 0.1 mm as the variation movement, that is the area between the two parallel straight lines in the plane containing should be considered line or axis, that is tolerance value is distance between these two lines. Similar pattern we have flatness. So to control the flatness of a surface, that means if this is one flat surface and second flat surface over here, then we can consider these two flat surfaces and the distance between them can be indicated. Likewise we have roundness, then we have cylindricity. So roundness will be used to show the perfect circular area throughout the surface, that is the ovality over here. So two circles will be used to control the errors of the roundness. So area between the two concentric circle will represent the tolerance value, that is the radial distance throughout from the center should be perfectly correct. Then we have cylindricity. So cylindricity will be used to control the combination of roundness, straightness, and parallelism of a cylindrical surface. So compared to roundness and cylindricity, cylindricity will be throughout the length of the component, that is the annular space between the two cylinders. So this will consider or act as a cylinder, and this two line will indicate the 0.1 value, that is the distance. Over here again we have a 0.1 distance. Then we have parallelism. So parallelism will be used to control the parallelism of a line or a surface with respect to some of the datum. That means two surfaces should be perfectly parallel to each other. Then we have squareness. So squareness will be used to show perfectly perpendicular regions and the square zones, that is to control the perpendicularity of a line with respect to the other datum surface. So in this figure, if you observe, this will be the datum surface, this will be the reference. So area between the two parallel lines or a space should be perfectly perpendicular to each other. In similar case, angles can be shown. We have angles over here, so angle can be considered. Then positional tolerance. So positional tolerance, we have datum surface over here and tolerance value over here. So perfectly, what we can say, this round surface should be perfectly concentric with this round surface. If we have a reference of round surface over here, then this axis may vary accordingly. So to control the deviation of the position of the center, that is our axis tolerance circle. Now important part, feature control frame. Feature control frame, that is three blocks which we have seen. So what we can say, first block was considered as a geometrical symbol, so which is will be connected to the tolerance featured with the help of a leader line and an arrow. Then we have in a second block the different geometrical symbols with the geometrical dimension, that is stated tolerance we have. And then important over here is modifier. Modifier will vary according to the requirement. Maybe we say maximum material limit, minimum material limit, or radial, or what it will change. And third block will consist either a single datum surface, or we can provide 2 to 3 datums. That is, first alphabet will indicate primary datum, second alphabet secondary, and third alphabet will indicate the tertiary datum. So in this way we will be using a tolerance frame or a control frame. So thanks to inspection expert for providing such figure. Then we have the different 7 modifiers, or what we can say, the M modifier in earlier feature which we have seen. So we have L for least material condition, M for maximum material condition, T for tangent plane to tangent surfaces can be shown if you want to show the projected zone. Likewise free state, diameter, radius, and sphere radius. So following may be the extensions, or what we can say modifiers, which can be used to show in the tolerance feature blocks. In relation to that, we have dimension, origin, depth, all round. So following can be the symbols which will be used. Again we have positioning over here, straightness over here. So straightness is shown in this fashion over here. Again we have straightness. So maximum tolerance value was 0.02, so which will indicate as either 16 or 1589, that is 16H1 region. Now how it means, so this is a cylinder, perfectly it should be a straight with respect to the datum. So maximum tolerance or allowable tolerance will be 0.02 mm. So within which we have a maximum material limit, what we can say. So maximum material limit will be this, either minimum or max value, that is limits within which it should lie. Similar case over here in case of angularity. So we have to find out the different medians which are derived line of the feature actual local size. Then we have straightness as discussed, that is the tolerance zone shown over here. So cylinder must be straight within the given tolerance, that is 0.03. Then we have roundness. So roundness will be considered within the tolerance, this one 0.05. Then we have perpendicularity, that is straightness. Or we have parallelism with some sort of modifiers, that is material limits. Then with respect to the, or either we have concentricity. Then we have geometrical tolerance with respect to this. So following will be the good examples related to angularity, perpendicularity, parallelism, likewise. Non-circular, non-flat and non-cylinder component we can indicate as non-circular, which will say that the radial distance is away, with non-flat condition parallel lines, and non-circular, that is axis will not be perfectly straight. The next part relates with the surface roughness. So surface roughness has the different scratch marks on the surfaces. Now that surface roughness can be indicated as the roughness values starting from 50 micron to 0.025 micron. So again that the same will be represented as a grade number starting from N1 to N12. So roughness will vary from N1. Maximum finish will get it at N1. Again we have a symbol for that. Four triangles will be used for representing the high surface finish, and a single triangle to no triangle will represent the somewhat rough finish. Now again we have based on the machining method, so sand casting is there, then we have super finishing, and likewise it will vary. Then we have milling and roughness symbol as A, B, C, D, E, whereas A will represent roughness value, B production method over here which can be represented over here, likewise sampling length, direction of lay, machining symbols. So this will be the symbols indicating whether the material is to be removed or whether the material is not to be removed. C in bracket F or either B will represent some of the production method, whether it is casted component, whether it is finished component, and likewise, or if some of the heat treatment processes are provided on that. So following are the reference that from which the course has been taken. So thank you for completing the course. We'll continue with our different courses in our upcoming. Thank you for attending.